This video is going to show you how we construct a simple circuit for the steady hand game. In order to do that, I actually need to change from basic circuits to electronics, which gives me just a couple of extra options within the selection of components. So I've changed it to the electronics from basic circuits. So we go electronic components and basic components and symbolic. So it's very similar to where we were before. We're going to bring in a battery, we're going to bring in a form of a switch, we're going to bring in an LED, and we're going to bring in a limiting resistor. So we've got a configuration very similar to this one. Okay, so there's our power supply. Then we're going to bring in a resistor, a push to make switch, slightly different version of a switch here, and then a light emitting diode. So if I connect those up, what we should see quite straightforwardly is a circuit which, when triggered, causes the LED to light. I'm going to just change the value of my resistor to 470. Remember, the unit of resistance is an ohm, OHM. So we've got a 9-volt battery. When the switch is closed, the power is able to flow through and cause the LED to light. Now you'll notice the difference between a push to make switch and a single pole single throw switch is that the single pole single throw, once you've triggered it, remains closed. This one is very much like a doorbell. When you press the button, it closes, allowing the electrons to flow, but the minute you release the button, the connection's broken and power can no longer flow through. So for our steady hand game, that would be incredibly quick. We'd begin to miss out. We might miss it if somebody touches the circuit. So what we're going to do is we're going to add a little bit of a time delay using a component called a capacitor. And specifically, we're going to use this one. It's an electrolytic capacitor. Okay, so there's our capacitor. Now, a capacitor acts in some ways like a rechargeable battery. It even looks like a little battery in many formats. And it can hold a certain amount of power. It can hold a charge. And afterwards, it can release that charge. So we use that to create a bit of a time delay. Okay. I'm going to just move my resistor. I'm going to rotate it. I'm going to delete my existing structure. Okay, so now what we've got the battery, the push to make switch. When I push it, power flows through here, through the limiting resistor, causing the LED to light. If I now move my capacitor into play and connect it up into my circuit, I get a slightly different result. Okay, let's move the LED across a bit. 9-volt battery, push to make switch, 470 ohm resistor, and that's 100 microfarads. Okay, and what you'll see there is actually a tumbling of numbers as the power is released from the capacitor. The minute I press the button to allow the current to pass, the capacitor fills up very, very quickly. Full capacity, and releases it, and then slowly, or relatively quickly, it releases its power back into the circuit. Okay, now I've got too smaller capacitor to show you in any detail. If I change that to 470 microfarads and press the button, what you can now see is that we're getting a delay of probably only a quarter of a second, half a second. But you can see, instead of it being instantaneous, I've now got a slight time delay, which is enough to register when somebody's using the steady hand game and they touch the track. Let's change that to 1000 microfarads. Okay, that becomes a millifarad. Okay, the amount of time that the bulb remains lit is increased. We've effectively doubled that, so we've got nearly a second of usable energy. That's actually still holding quite a large amount of charge. So remember, in this circuit, what we've got is the 9-volt power supply. When the switch is open, no power can pass. When the switch is closed, power is able to flow down through here. It charges the capacitor and continues on. It charges the capacitor up. When the switch is broken, no more power comes down here. And as a result, power begins to flow out of the capacitor and making this almost a sort of a little sub-circuit. And it flows down here and to the negative rail. So the capacitor acts as a slight power supply, causing the LED to remain lit for a period of time afterwards. And that's quite useful in circuits because it helps to stop any sudden loss of power which can damage components. It can help to smooth out the electrical signals. So capacitors play a really important role. In our case, we're using them as a timer.